Okay, good morning, everyone. Today, we're going to continue our discussion on panel data regression. I provided here some notes because I realized that there were many questions last time about the nature of fixed effects and random effects. I hope these additional notes, we're not going to really discuss everything here. These notes are provided for you to read through. Okay, I'll just go over some of the points here in order to clarify the difference between fixed effects and random effects. So last time we discussed that as far as panel data regression is concerned, there are three main methods. You have the pooled OLS, fixed effect, and random effects. Of this, the quote-unquote weakest is your pooled OLS because it disregards altogether the individual effects of the units or the let's say of the individuals, whether it's firms or countries, etc. And if these countries, if these firms, or if these units have some innate characteristics in them that differ from among each other, and that are fixed, maybe fixed over time, then we, if we're using pooled OLS, then we're just disregarding that. Okay, so we say that this is quite unrealistic, that we don't have any differences in terms of attributes among the units. Now, these differences could also be called unobserved heterogeneity. You know, heterogeneous means they're different, like as 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 distinguished from homogeneous. Okay, so there are differences, and these differences are considered as fixed for each individual or unit. So that's what happens when you do fixed effects. An example of that is, for example, an example is you have several firms, okay, and then they could have different corporate culture, and this corporate culture could affect, let's say, you're looking at profitability. So if this individual attributes like corporate effects, corporate culture might be different for each of the countries. Okay, so I gave here an example. Let's say, let's take a look at the effect of education and income. So income is your dependent variable. Education is your independent. Income is your dependent. Education is your independent. Okay, so you're taking a look at several countries, or let's say several companies. Okay, now companies, okay, may have, sorry, yeah, let's take a look at countries. So as far as countries is concerned, they may have different characteristics, like cultural factors or geographical factors. And these factors, cultural factors and geographical factors, are what we call our unobserved heterogeneity. So they're not found in the data, okay? Okay, and they don't change over time, okay, which means they remain fairly consistent. So usually cultural factors are oftentimes, maybe they're embedded in the psyche of the people in the country. So it might take some, I don't know, perhaps some evolution in as far as the company or the country is concerned for this to change, okay, over time, okay, or on an annual basis, if that's our data. So these are examples of characteristics, cultural or geographical, okay, and these don't change over time, okay. So fixed effect will allow us to control, okay, this what we call unobserved heterogeneity, unobserved heterogeneous factors. We control for them, okay, because they are assumed to be constant and fixed over time. So technically, each country will have its own intercept. If you recall, in regression, we have our model and there's an intercept. And this intercept referred to, since we're in regression class, okay, uh, the intercept refers to the value, okay, of your dependent variable when all the independent variables are all equal to 0. So in a panel data, since you have different units, right? You have several units in several points in time, then you'll have this individual intercept, okay? But we don't directly estimate these intercepts. Instead, we control for them. But we can, of course, we can show what the values of these intercepts are, okay? So we don't necessarily show them, we don't necessarily compute for them, okay? We don't estimate them, but it can be estimated, of course. We control for them. That's why there was a question, I think it was Ian last time, who asked, why is there no intercept in a fixed effect model? Precisely because of this. Okay, this is the reason. Okay, we're not estimating these individual differences. Instead, we control for them. And what's the meaning of controlling? Okay, controlling is oftentimes used in regression. Okay, we would want to isolate or eliminate the effects of these qualities that do not change over time, in as far as determining or establishing the relationship between your independent and your dependent variable. Sa data natin, class, nyari yung, di ba, firms yun, di ba? We have 10 firms, and then we were trying to establish the relationship between investment and value and capital. So a possible intrinsic attribute will be, for firms, as I mentioned, it can be corporate culture. So we're not directly measuring the effect of corporate culture. What we're doing is we are controlling for this heterogeneous, okay? Okay. Sorry. Itong term na to, wala tong. What happened to my mouse? Ito, class, yung unobserved heterogeneity natin. Okay, which is corporate culture. So we want corporate culture not to mess with the association between investment and value and capital. Okay, we want to isolate it. Okay? We don't want it to affect or bias the relationship that we're trying to study. Dun sa data natin, Grunfeld, our dependent variables is investment, our independent variables are value and capital. So there might be individual effects among the 10 companies, and we don't want these individual effects to be affecting the relationship between our dependent variable and independent variables. Okay? So there's this term, confounding variables. Okay, these are variables that might affect both the independent and dependent, leading to inaccurate conclusions if not considered. So confounding variables are variables that affect both the independent and dependent variable. So I said here, class, that we're controlling for these individual attributes, the individual effects. Okay? When we say control, we make sure that the impact, the effect, in particular, the effect of this, let's say, corporate culture on the independent variables. No? That's in random effect, in fixed effect, that's what we're trying to avoid. Okay, it helps ensure that the effect you're measuring is not distorted by these factors. Okay, so for example here, okay, sometimes they consider age as fixed over time kasi yung effect niya on a yearly basis 1 year lang naman, no? So sometimes they consider it as fixed over time. Okay, so when we, let's say, of course, age has an impact on income. Income is your, okay, okay, age may have an impact on the relationship between education and income. Okay, so when you control for age, you'd like to ensure that yung relationship ni education and income will not be affected, will not be biased because of the effect of age. So we don't want age to be entering the picture. We only want to see the effect of income on education. Okay? Right? sorry, vice versa, education on income. All right, so what do we mean by controlling for unobserved heterogeneity? These are your individual effects. Okay, so I already mentioned this a while ago. To control for these factors, okay, like natural culture or economic stability, okay, we use fixed effects in our model. So this will effectively adjust the differences between countries. So what we're doing here is we're removing these effects. Okay, we remove the effect of this unmeasured. Okay, it does not it's not stated in it's not a variable itself. Okay, itong constant na to na country specific factors. So as I said a while ago, we are isolating the effect. Okay, we're isolating the effect of uh, we're isolating the effect of these individual factors, individual effects on our independent variable. So how is the control done? By demeaning. Okay, when you say demean, okay, what we do is we subtract, okay, the average of each unit. Okay, so what we're doing is now leveling, okay, leveling the data. Okay, so these are more no intercepts again, and explain ko siya, okay, and demeaning the data. Okay, this is just an additional explanation. Okay, so I want you to read this. I put something here that has something to do with intuition. Okay, for example, if you're studying the GDP growth in different countries, the fixed effects will control country-specific factors, size, geography, political stability, okay, which don't change over time. Okay, we're not trying to predict GDP, the GDP level of each country, okay, which could be yung absolute GDP level, yung average, no, which could be represented by the intercept. What we're predicting is the change in GDP growth for each country over time. Okay, so we also have a brief discussion here on random effects. Okay, so sinamarize ko siya, class. A fixed effect versus random effects. So ang assumption natin dito yung unobserved heterogeneity. Sa fixed effect, it's considered as constant over time, while for random effects, random siya. It's not constant over time. Otherwise, it's random. So if you take a look at the equation, the regression equation, you have y is equal to beta null plus beta 1 x sub it plus epsilon I sub it. Yung individual effects na yun is not part of an alpha sub it, alpha sub I, but rather it's part of your epsilon. It's part of your residuals. Okay? It's part of your unexplained sa residuals class. Treated as part of the error term. Okay, when do we use fixed effect? Okay, yung individual differences natin, yung country-specific effects, yung country-specific factors, are correlated with your independent variables. While on the other hand, pag random effect, hindi siya correlated with the independent variables. Okay, if this is the case, kung may correlation yung country factors at saka yung independent variable, then if we're going to use random effects, then it will be less efficient. That's why we use fixed effects class. Kung may correlation yung country-specific effects at saka yung independent variables. Okay? All right. So, okay, I think that's all for just an additional explanation based on our discussion last time. Okay, then let's go to, okay, the other one that I sent to you is, ito yan, di ba? Saan yung module natin? This one. So maybe you'd like to copy this and put it in your RMD file, kahit siguro dun sa, maybe a new RMD file, or in the old one, We just have to situate it. Maybe as I show the RMD file, no? Alam nyo kung saan nyo ilalagay yung portion na yun. Okay, let's go here. So last time, let's have a quick review. Make sure that your packages are loaded. Okay, these are our packages. Saan na siya? PLM, LM Test, Stargazer, NLM, EPGMM, and PLGM. Okay. Now, by the way, class, definitely will not be able to reach SGMM, but there are many materials on that. And then I would encourage you, class, to do the bonus for that and include the SGMM model. Kasi pwedeng maging ano niyan, pwedeng maging paper nyo later on yan. This could be a tool that you may be able to use, and this expands. Dati kasi panay ano lang, panel data regression, ina-address yung problems with the model. Okay, pero hindi na nag-attempt mag FGLS. Now, I think beginning 2 terms ago, require ko na talaga yung mga students who are doing this to test their model and to see if FGLS would be a better alternative than just panel data regression. Okay, so we said that Grunfeld is a data frame, so we have to convert it into a panel data. If we're going to do panel data regression, the data that we're using should be panel. So this is the code that we used. We created this object pdata. We use this panel linear model. The function is pdata.frame that converts Grunfeld from a data frame into a panel data. You have to identify the index. The index will be the individual and then the year. Okay, the individual and then the year. First is the individual, the unit, and then the year. Okay, would it matter, class, if ma-interchange to? Okay, possibly, kasi magiging ginawa ko na dati yan eh. Okay, so ito yung naging this one became the individuals, no? 20 individuals, and then 10 years. You may wish to experiment on that. Okay, we're not going to do that anymore, but make sure that you identify first the unit. Okay, so I have that. I'll get the structure of P data, and you have that too. You should. Otherwise, you just rerun the first portions. Okay, so here we have P data.frame, and it's also, in a sense, data frame also. And then you can see here the index firm. Okay, the indices should be factors. So this is a factor with 10 levels. Okay, so we're okay. Okay, and then also, if you take a look at the year here, $year, this is also a factor with 20 levels. So just make sure that your indices are factors. Otherwise, magkakamali. Otherwise, it means that you haven't converted your data into a panel data. Okay. All right. So let's, after making sure that our data is panel data. Okay. So let's now run the run the methods. First is your pooled OLS. Okay. If I run this, then you see that okay. Pooling, balanced panel, 10, n is equal to 10 and p is equal to 20. Okay, if you made a mistake before, then this could have become n is equal to 20 and t is equal to 10. Okay, and we don't want that. That's wrong reading of the data. Okay, and you see here the intercept, value, and capital. Okay, so what happens in a pooled OLS, although the predictive power, 81%, is quite high, okay, but that should not be the main basis for choosing pooling. Okay, because uh, theoretically, this is infirm. Infirm, so medyo mali siya, no? Kasi ang assumption niyan, all firms behave the same way over time. So walang distinction, walang difference between firm 1 up to firm 10, which makes this model quite unrealistic. So pasok si fixed effects. Okay? So we're going to the code that we use is data is equal to p data and model is equal to within. Okay, so if we run this, notice that that's why there is no individual effects, no? So tinatanggal siya because we don't want to get it in the way of of associating our independent and dependent variable. So we have value and capital. Okay, adjusted R squared is 75%. Okay, so okay yung model natin. Okay, and if you compare this with our pooled, dito class, si value natin 0.115, 0.23. Dito naman, si value natin 0.11 and then 0.31. Okay, so, and then wala yung intercept natin. Okay, now, is it possible to get the values of the individual units, yung ano nila, yung intercept? Yes, we can do that. No? We can do that. Pwede natin kunin yung ano yung coefficients ng mga ano natin ng mga individual units. No? Okay, let's do that. So the code for that is this one. Okay, here I created. Okay, let me just share this code with you, class. Again, because of time constraints, Control C, and let me chat this with you. Okay, chat. Here, Control D. Okay. All right. So this one is the same, class. Kasi towards the end, I used a different name, FE model. I forgot that I used fixed, so nag-error siya. Kaya ginawa ko na lang to para yung mga codes ko sa ilalim will still be okay. So I created another object, FE model, which is exactly the same as my fixed model. So it's PLM, investment associated with value and capital. Data is Grunfeld, model is equal to within, as compared to the pooling method here, okay? Model is equal to pooling. Okay. All right. Pooling versus within. Okay. So if I run this, I'll generate the same result, only that I have another object, FE model. So it's the same. Okay. Nagkakaproblema nga lang ako sa view, no? I don't know why, but okay, anyway. So this is the same thing as our fixed. Okay, and if you want class to get the individual intercepts, you can use the fixed f. Okay, this is the function to get the fixed effects. Okay, so here I created this object individual intercepts, and then let's print it. And then if I run this, then okay, 1 up to 10. And those are the values of your dependent variable investments. Okay, when your value and your capital are zero for each of the units. Okay, so that's the intercepts class. Those are the intercepts. So unit 2 seems to have the highest. The others are negative. Negative yung investments nila. Okay, so this what I want to tell you, that the individual intercepts can be computed. Pwede siyang makompute, pwede siyang makita, but in fixed effects, tinatanggal talaga siya. For the reason that we don't want it to get in the way of distorting or biasing the relationship between your... Kasi pag meron to class, then may iba yung ano, maiiba yung parameters natin for capital and your value. So the entry of your intercept class will now change the value of your coefficients, value and your capital. All right. Uh, did you get this class? Any questions about that? Kindly chat, please. I'm sorry. Are we okay, class? Kindly chat. Okay, how about the others? Hmm. What do you mean wala pa yung code? Wala yung code. Which one is this? Sorry, hindi ko nakita yung... Micaela, ano yung question mo? Wala pa yung code.
Ah, sir, wala po yung code niyan po na pinapresent.
Which one? Ito?
Opo, sir. Like, hindi pa po nabigay na send sa chat box.
Ay, wait. Sorry, na-chat ko kay Zul pala. Sorry. Sorry, class. Listen lang. Okay, Control C. All right. Okay, there you go. Sorry about that. So you can run that class. And you can see that the individual effects will be, the individual intercepts can be obtained from the fixed effects model. And this is what's, as we said, yung individual effects na to, which are considered as constant over time. These are the ones that are disregarded. Okay, but we don't negate the fact that there are individual differences. So that's the fixed effect model. Okay, so it controls, the term that we use is it controls for this firm-specific effects. We don't want this individual effects to get in the way of establishing the relationship between your dependent and independent variables. Okay, so if these fixed effects are correlated with your regressors, which are your which are your value and capital in our case for the Grunfeld data, then fixed effect remains to be or is the best model to use. Otherwise, if these fixed effects are just random, okay, they're just random, they're not related to the regressors, then random effects is the better model. Okay, so how to do the random? Same thing. We're regressing, associating investments, investment associated with value and capital. Same data, but the model is random. And we see that the result of this is, okay, this one, you have this balance, and last time we discussed this class, no? The effects, idiosyncratic effects and your theta. I think I I have here additional notes. Okay, so let me share this with you. Okay, up to here, 2 times Control C from my experience, and then chat. Maybe you'd like to add this also in order to add on to the discussion of or explanation for your idiosyncratic and individual. Okay. You may just include that here, class. So I think I gave you this notes up to individual panel. So you can add this one. Okay, and then I provided here the formula. So the formula is not a proportion. Okay. It's the ratio of your idiosyncratic error to this function. Okay? All right. So I'll not go there anymore. Okay. Do you have this note, class, what this means for the model selection? Can you please check? I think this is given, right? Yes, okay. All right. I won't copy that anymore. All right. Then what do we do, class? I will not discuss anymore the idiosyncratic and individual. Okay, then after having identified, developed, or generated the pooled, fixed effect, and random effects, what do we do? We have to compare, class. We have to know if are the individual effects, are they fixed over time, and are they correlated with our regressors? Because if not, if there's the presence of individual effects, however, they're random, okay, they're not really fixed over time, then, and they're not related to the regressors, then the random effects model should be the better model. So how do you do that? We compare. Okay, we can compare first pooled OLS and fixed OLS, fixed effects. And usually, if fixed effect is better, it indicates that there are individual effects. And random effects also acknowledges that there are individual effects, only that it's random. While in fixed effect, it's fixed across time. Okay, so if you test pooled versus fixed, actually there's no more need to test pooled and then random. But as I said last time, I still provided this. Okay, there's no harm in testing both. Okay, but you can also do just pooled versus random. And if random is the better choice, then you jump to random versus fixed effect. Okay, so here we're using F-test. And the null hypothesis is that there are no significant effects. Because that's what pooled OLS is all about. Okay, so let's run this. Okay, tagal. All right, so here you go, class. The p-value is much lower than 0.05. Therefore, what's our conclusion? This is a rejection of the null hypothesis that there are no significant firm specific effects. There are. There are. So, sorry, I jumped to the pooled, no? Sorry, yeah, I'm correct. All right, so we reject the null hypothesis that there are no individual effects, specific effect, individual unit-centric effect, firm-centric effect, firm-specific effects. Those are names, okay? So we reject pooled OLS. But this does not really establish the fact that the individual effects are, it just tells us that there are individual effects. As to whether they're fixed over time or they are random, we don't know yet. But we can go anyway to the random effects. We're using here Bruce Pagan. So type is equal to BP and run this. And just like the first one, the null hypothesis we can put here, may wish to put here, HO, is that there are no or just specific or there are no significant effects. All right, just like the first one, the F-test. Same thing with the Lagrange multiplier Bruce BP test. And as expected, your p-value is way low, way below 0.05. So there are no significant effects. There are significant effects. We reject the hypothesis that there are no significant effects. All right. Okay, then lastly, in order to determine are the fixed effect, are they fixed over time? Okay, are they correlated with the are they correlated with the regressors? or they're not fixed. They're random, and they are not correlated with the predictors. So we use the Hausman test. So panel Hausman test, fixed versus fixed and random. Okay, and the null hypothesis is that the the effects, the individual effects, are just random. They're not fixed over time. And the value of the the p-value is 0.3. So our inference here is that we fail to reject the null hypothesis that, okay, the individual effects are random. Okay, so we choose the random effects model. So with this, we do not choose the pooled OLS because there are individual effects that are significant, and then we choose the random effect model because these significant individual effects are not fixed over time. They're random, and they're not related with the with the independent variables. Okay. All right. So, okay. After that, as in any regression model, we have to do diagnosis. So this one I gave to you. The first one that we're going to do is heteroskedasticity. Okay. We'd like to see if the residuals are heteroskedastic. Okay. So it's very easy. We use BP test. Okay. Bruce Pagan test. You have the model here. You have data. And then we just impose that the residual should not be normalized. Studentized is equal to false. Do not convert the data to normalized data. Okay. Otherwise, it might give wrong results. Okay. So if we run this, the null hypothesis, by the way, is that the residuals are constant or the residuals are homoskedastic. So if we run this, okay, the p-value is way below 0.05. Therefore, we reject the null hypothesis of homoskedasticity. Okay, rather the residuals are heteroskedastic. Okay, all right. If this was only the problem, class, if this was only the problem, then okay, if you open, class, the other file, okay, I think I better go here now. If you open the other file where addressing diagnostics, we can now, okay, we can now go here and okay, address the heteroskedasticity. So when you address heteroskedasticity, what can be done is we adjust the standard errors. Okay, the problem with the heteroskedasticity is the standard errors. If you recall from your regression class, di ba? Yung okay, you have your coefficient, you have your beta, and then you have your standard errors, and then your t-value and your p-value. This is the regression model. Okay, so you have your intercept, you have your standard errors. There's no problem with the intercept, with the coefficients, class. No problem with this. The main problem is your standard errors. Okay, your standard errors could be wrongly specified because of the heteroskedasticity. So what happens when your standard errors is inaccurate, is wrong? Then your t-value will be wrong. This is correct. This is wrong. So your t-value might be wrong. So if your t-value is wrong, then your p-value is wrong. So you might have wrong or biased inferences because of these standard errors. Okay. So what do we do? In order to address heteroskedasticity, we address the standard errors. And one way to do that is by using the variance covariance robust, we call it the robust standard errors. So what's done is to adjust this, okay? adjust this so that it will not be quote unquote erroneous, not necessarily 100% correct, but we adjust the standard errors. If we adjust the standard errors, then our t-value will be more accurate, and our p-value also will be more accurate. Okay, so the problem with heteroscedasticity can be now addressed by using what we call robust standard errors class. Okay, and in R that's very easy to do because we have this function variance, covariance, heteroscedasticity, consistent, and class. Heteroscedasticity robust covariance matrix. Heteroscedasticity consistent standard errors. All right. So this is class. This is in the other Word file that I gave you. So you may wish to put that class in another RMD file. Okay. All right. Then let me delete this and close this. And the code is very easy, class. Okay. So what does VCOV HC do? Okay, it will compute now for heteroscedasticity robust covariance matrices, which will now adjust the standard errors. Okay, so it will help correct standard errors. Okay, and then it will prevent misleading p-values, which I mentioned a while ago, and incorrect statistical conclusions. Okay, without the robust standard errors, the random effects model may underestimate or overestimate your standard errors, leading to wrong t-values, wrong p-values. So wrong inferences. So very simple lang class, no? Yung pag-correct ng standard errors, converting them into robust standard errors. Ito lang class. VCOV HC, then this is our model random. And type, there are several types, no? HC01, HC, for in correcting heteroscedasticity, we normally use HCO, which is the Arellano method. Okay? So if we run this class, okay, let me run this. Okay, run. Andito naman yung random natin, no? And if you copy this class in another RMD file, pwede nyo pa rin ma-run kasi nasa environment naman si random. Okay, let me run this. Okay. And then, kunin natin class yung yung coefficient, no? Okay, we apply this robust standard errors to the model. So we run this code, coefficient test, okay? Random, where the variance covariance is equal to this one. Robust standard errors. Okay, run natin. All right. So what happens here, class? What happens here? You now have another model, okay? Now, the estimates will be the same. Diba sabi natin, hindi binabago to. But there will be some changes in your standard errors, which could result in differences in your t-value and in your p-values. Okay? So, asan na yan siya? Let me run the, asan na si, natin, si random natin. Okay, where is our random? Sa taas. Ito, ano ko na lang to Control C. I'll copy this down here. Asa na si... HC0. Here, class. Ilalim lagay ko summary. Random. Okay. Ay, sorry, clustered na pala to. Control X, dito tayo sa ano? Dito tayo sa, dito. Okay. Here. Control V. So, iraran ko both yung adjusted, robust standard errors adjusted, at saka yung original natin. Run. Okay, you have two models here. Okay. So the first one is yung na-adjust natin, no? Ito. Notice that yung pangalawa, the second one is this one, yung random natin. And the estimates are the same, 0.109, 0.308. Same yung class, same. Walang nagbago. Standard errors, 23.01. Ano nangyari dito? Standard errors, sinabago siya, no? Nabago yung mga standard errors natin. And then notice, hindi na siya t-value, z-value na siya. Okay? And the probabilities were also changed. 0.04, ito 0.01, okay? Okay, ito class, no? Although hindi naman nabago yung ano natin, yung estimate natin, no? Hindi naman nabago yung ano, yung p natin, nabago yung absolute value but it's still less than 0.05. So what changed, class? In this case, nothing changed. Yung pa rin yung estimate natin. But now you can say that na-address natin yung heteroscedasticity. That's the point here, class. So in your paper, for example, you can say that the residuals of the model turned out to be heteroscedastic. However, this was addressed by using robust standard errors. Yun ang point doon, class. So na-address natin heteroscedasticity. So the same thing through, class, I think na-mention ko to dun sa sa regression. Ganun din sa regression, in any regression. If there's heteroscedasticity, then it can be addressed by using this one. Okay, the next, class. Punta tayo ngayon sa next test natin. So if in that case, that addresses now the the heteroscedasticity. Pangalawa, class, which we did last time. How about the serial correlation? Okay, may problema tayo sa class sa serial correlation if if correlated yung mga residuals natin. Okay, so for serial correlation, there are two types. Merong serial correlation for fixed effects and meron for random effects. No? For random effects, ang ginagamit natin si Baltagi and Lee. Sa fixed effect, ginagamit natin si Wooldridge test. Okay, since we're running random, then we do this. So if we run this, class, again, ang null hypothesis na to, no serial correlation. But the statistical test tells us that merong serial correlation. We reject this null hypothesis. Okay? So may problema tayo. So sa model natin, class, if there is heteroscedasticity and if there's standard serial correlation, we have a problem. Okay? Kasi hindi na reliable yung result natin. So that will call for the feasible GLS, which is part of your case, no? Kailangan mag-FGLS tayo. Pero class, let me point out. Di ba we already addressed heteroscedasticity? And we can also address serial correlation. How do we do that? Balik tayo dito sa baba, no? Which is in the other, yung kasama dun sa addressing class, no? So I hope I hope you to addressing, no? Yung pangalawa naman, class, ito. This is now the second one. Okay. Okay, in-explain ko dito yung what these results mean. Okay, so please read that. Okay. Now take note, class. When we do corrected, robust standard errors, heteroscedasticity is not removed. However, the impact is corrected. Okay, please take note of that. No, you don't actually eliminate heteroscedasticity. We cannot fix heteroscedasticity, but we can adjust it. We can adjust for it using our robust standard errors. Okay. Okay, if you, as we said a while ago, how do we know? Compare nyo, class, no? Yung standard errors dito, for example. Standard errors 0.01 dito, 0.012, 0.05. Ito, 0.01, 0.017. Where it matters, class, ito kasi yung independent variables natin, di ba? Sa intercept, okay lang yun, class. No problem. 23, 28, hindi naman predictor yung intercept eh. Pero class, tignan nyo dito, yung standard errors natin ng value at saka ng capital. Diba? In fact, yung probability niya naging way low, diba? As compared to this one. Right? So the p-values were really reduced. So mas naging significant siya. So you see that there was a change in your in the measure of your heteroskedasticity. Hindi na wala yung impact. We cannot fix it. Na-remove pala yung ano, na minimize yung impact. It was corrected. All right? I hope that's clear, class. Okay, ito, please read this. Okay, the significance of the coefficients might change if heteroskedasticity was a major issue. Okay, next, yung serial correlation. I'm sorry, 5 minutes na lang ako. Okay, ganun din, class, no? We can address serial correlation. Again, using this VCOV HC, type naman is equal to HC3. Okay, so very powerful to class, no? And then you have to define that cluster is equal to group. And then ilagay natin dito nga yung summary ng random. Okay. Compare ulit natin, class. Alright? So ito yung ano, di ba? 0.01. Okay. Hindi. Sorry. Okay. Iba yung mini-measure natin dito yung serial correlation, class. Kaya hindi natin siya pwede i-compare dito. 0.01, 0.017. Ito hindi, class. 0.01, 0.06. So this measures serial correlation. So when we use HC3, class, what happens is that, okay, this is a robust variance estimator that will adjust for ito, class, both, no? Heteroskedasticity, but much more yung serial correlation. Okay? All right. So it explains here what this does. So I leave you, class, to read this. Okay? So na-address, class, yung serial correlation. Now the question, na-address ng heteroskedasticity, na-address na yung ano, na-address na yung serial correlation. Okay na ba yung model natin? Okay? Okay na ba? Does it mean that it's now okay for us to not to go to feasible generalized least squares? Okay, because as I said, if there's heteroskedasticity, if there's serial correlation, then you have to do feasible GLS. Okay. So I made some notes here, which I hope you read, class, kasi andito yan, no? Okay. Sana ba? Okay. Okay. Meron akong binigay din ano, Okay. Sana ba yan? Okay. Hindi ko makita. Sorry. Okay. Anyway, class, itong write-up na to, class, which I shared with you also, you have to read this, class, kasi kailangan sa case yan, eh. Okay? So, sabi natin, di ba, tatapusin natin yung ano dito, yung panel data. The notes are actually with you here. Andito rin yung mga code dito ng FGLS. So, I hope this serves, class, as a ito na yung parang ano natin, asynchronous, no? Okay, so when should you use FGLS? There is heteroskedasticity. There is serial correlation. Okay, and then random effects is preferred over fixed effects. Okay, of course, if fixed effect is preferred over random effects, we're not going to talk about FGLS. Okay, and then here are the steps. Here are the steps. Tapos binigay ko na rin, class, yung code. Okay, simple lang yung code, no? Ito lang. That one. Okay, it's not a big code. It's a very simple code. However, kailangan intindihan yung output, no? Kasi isasama yan. And I already provided here some notes. Okay, so it's just up to you to study. Okay, so college naman tayo, class. So I'm sure you'll do invest in time, class, studying this kasi this will be important for your paper. Okay, so hindi ko na, class, pinakita yung it's almost time, class, yung cross-sectional. Let me just explain quickly. Yung third test, class, yung cross-sectional dependence. And ito, class, oops, sorry. I'm sorry. Ito class here. This is addressing here. Nawala. Sorry about this. Where's that? Hindi na. Control F. Pesaran. Ayan. Okay, here. Third one class is cross-sectional dependence. Yung cross-sectional class, you know what that means? Cross-sectional, di ba? Between firms, firm 1, firm 2, firm 3. Now, it's possible that the residuals of firm 1 is related to the residuals of firm 2. Ibig sabihin nun class, uh, merong spillover. I use that term kasi here. Okay, so kindly go through this class, no? Fixed effects to it. Ayan, ito, class. So there's spillover class. Ibig sabihin, yung residuals ni firm 1 nakaka-affect kay firm 2. And that happens. If that's the case, then there's what we call cross-sectional dependence. And there's a test for that class. And there's a remedy for that. Yung remedy na naman, yung variance covariance HC. Heteroscedasticity, consistent residuals or standard errors. So yung tatlong diagnostics class, that can be remedied by adjusting the standard errors, okay, by correcting it using the variance covariance HC, whether it's H0, H3, or H1. Okay, so that will correct class, that will address the problem. However, class, and this will be my last point, that will address the standard errors, but that will not address the coefficients. Okay, sa case nyo, you have to address the coefficients if necessary. Kasi, again, yung remedies na yan, it will only address the standard errors but not the coefficients. If we want to address the coefficients, then we have to use the feasible generalized least squares. Okay, so ang requirement sa case nyo, kailangan ma-address yung coefficients. Okay, you do also the test, you also do the remedies for the violations, if any, but you have to do the FGLS. Okay? So with that class, I hope ito class, dito na naman yung notes, kompleto na yan. And please take time to read it. Okay? It's not really difficult. And of course, you have all the resources in the world to also look at this. No? And kasama sa bonus class yung system GMM. All right, so let me stop recording now.